Hello everyone, welcome to Coders Camp. So this is our third video in Quicksort series where we are seeing how Quicksort works and what are the problems that can be solved using logic of Quicksort. In our previous video we saw three problems, that is sorting a binary array, separating negative and positive numbers, and assigning negative and positive numbers alternatively using quicksort partition logic. So here we are going to see another problem that uses the logic of quicksort to make it work really faster. So now we are going to see the first missing positive number in a given array. So the input given is an integer array which is having both negative integers as well as positive integers, and we have to return the first missing positive number. So for example, in the given array, let's start our first positive number ever is going to be 1, and it goes 2, 3, 4, and etc. So here in this array 1 is present, 3 is present, 4 is present. The first missing positive number is going to be 2 and we are returning 2. For example, if any array starts with 7, 6, 4, 8 and done, in this case our first missing positive number is going to be 1 because it doesn't have 1, and then 2, 3, then it has 4. So the first missing positive number is going to be 1. And one more example to go, that is if our array is 1, 2, 3, and 4. In this case, what is the first missing positive number? 1 is there, 2 is there, 3 is there, 4 is there. Finally, we have to return 5 because that is the first missing positive number in the given array. Hope I made the examples clear. So how are we going to approach this using quicksort? If it is a brute force, we are going to iterate our pointer I starting from 1 to size of the array, and it checks every time whether if one I is present in the array or not. If it is present, then iterate and check for the next element. 2 is present or not, 3 is present or not. If any element is not present in the array, then we have to return that element. This is going to take more time than what we are going to approach now because we are going to use quicksort. So where will be quicksort helpful in this case? So now consider this example. Here this array is having both negative and positive numbers, but we don't really have to care about the negative numbers because we have to concentrate only from the number starting from 1 or only the positive numbers. So if an array has negative numbers, you can simply ignore them. How do we do that? We get the help of quicksort to sort it greater numbers together and lesser numbers back. That is, after applying quicksort to this array is gonna look 3, 4, 6, and then -1 and -2. So here you can simply ignore this -1 and -2 by fixing the array iteration to this size till 6. We don't have to really think of or use the negative numbers here. So once you sort it using our partition logic, we're going to fix the size of the array till the positive numbers and search for our first missing positive number. So how do we do it? As we saw the partition logic in previous videos, if you're not familiar with it, please go and check the first video which explains in detail that how quicksort works and how we can use the partition function in few simpler problems in a second video. So now we are going to set a pivot element to 0. As we saw in our previous example, we saw one problem that sort the negative numbers to the left and positive numbers to the right. Here we are going to set pivot as 0, and we are going to check if any numbers greater than pivot gonna swap, less than pivot move the pointer. I'm not going to explain the logic here because we saw the same logic again and again in the past two videos. I'm just going to tell you the idea that we are going to check if it is greater than 0, then swap it. In that case, all our greater numbers than 0, that is positive numbers, gonna shift towards right, and negative numbers shift towards left, and the negative numbers gonna shift towards right, and it is going to return the pointer where our pivot is. Actually, we are not going to fix 0 here as a pivot, but it's going to return the index where our last positive number ends. Because in our partition algorithm have a pointer I at where the last number which is greater than or less than the pivot exists. So this position will give us where is our positive index ends, and by using that index we can iterate our array 0 to that index alone and leave the rest of the array. So this reduce the time to half or the number of elements present to iterate in positive index, and completely ignore the negative values or that much time it needed to iterate the array. So first we have applied quicksort and we reduced it half or split the array to positive numbers alone to iterate. So let us see the rest of the logic, how we are going to find our first missing positive number. So before getting into the logic of how we are going to find it, let's see our partition code. Here, as I said, I'm setting my pivot as 0. Every time I check if it is a greater number, then swap happens. And it returns j, which is actually the index of last positive number in the given array. We're going to use this index to iterate our array from 0 to j and find the first missing positive number. As we know, in one pass, quicksort partition algorithm will separate the positive numbers and negative numbers and return the index of last positive number. So now we are going to use the logic, that is, an array will be represented from the index 0, 1, 2 till n. The same way, the positive numbers will start from 1, 2, 3, 4 till n. So in this case, we are going to update the values index to negative number every time. That is, so now we are starting at index 1. So index 1 minus 1, that is pointing at index 0, we are going to set that index to minus. That is first index of our array with negative sign. So we are updating 1 to minus 1. So moving on to 3, we are going to set the index 3 to minus 1. This is the third index in the array, so we are going to set it to minus 4. So 3 is done. Moving to 4, we are going to set the fourth index to minus negative value. So here the fourth index is going to be minus 6. So moving on to 6, which is beyond the number, we don't have to really concentrate on the numbers after j. We're just going to update the numbers before j. And if you see, start iterating again, the first index is negative. In this case, the number 1 exists. The second index is positive, so we could find the number 2 doesn't exist. Because if the number 2 was there in the array, we would have set the index to negative value. We did not set the index to negative value, which means we don't have a 2 exist in our array, so that is going to be our first positive missing number. So we are going to set the index value to negative value and iterate it again to check if there is any positive number exist. If there is a positive number exist, then we are going to send the index as the result. If not, if all the numbers are set to negative, in that case our j iterates till 4. So we have 1, 2, 3, 4, and finally fifth number will be the first missing positive number. In that case, return j plus 1 as our output. So this case will contradict in two situations. The first situation is, what if the number has a duplicate? That is, if an array is 1 comma 1, in that case it first check the index of the first number and set it to minus, and again take the index of the first number and set it to plus. So once you update a number twice with negative value, it will turn back to positive value. In that case, we are going to check a condition every time. If the number we take is already negative, then leave it. If it is positive, only then we are going to update it to a negative value. This is one case. The other case is, So once we set our index to minus value, next time we iterate and gonna take this as our index. That is, for example, array of minus 3 is not a valid index. The index should be a positive value. So we are going to take in terms of index every time math dot absolute. The absolute value of minus 3 is going to be 3. This is what we're going to access as the index. Hope you're getting the logic. So let's go for a dry run with another example for clear explanation. So here is the second example. We are going to take 4 as our first number. So we are going to update the number at fourth position to negative value. So number at fourth position is this. We are going to update it with negative value. So 1 becomes minus 1. Again, the next number is also 4. So in this case, we have to update our fourth index to negative value, but the index is already negative, so we are leaving it and moving to scan the next element. So our next element is 2. Now it's time to update the number at second index or second position to negative value. So here we are going to update 4 to minus 4. Moving on to our last number 1. So we are going to update the number at first position to minus value. So now we are going to update 4 to minus 4. So we are done iterating this given array. So it's time to scan our negative numbers array. So now start scanning from minus 4. So the first index is negative, so 1 exists. Moving on to second index, the index also is negative. So we are moving on to, so 2 exists, we are moving on to our third index. Third index is positive. So in this case, we don't have 3 exist in our array, so we are going to return 3 as our output. Yes, of course, we don't have 3 in a given array, so that is going to be our output. Hope you understood the code. So now let's see how we're going to code it. So as we explained the example already, right away go to code. So here is our partition function. As I said, we are going to sort the array first positive values and then negative values and return j. J is the last index where the positive number ends. So now using that, we are going to set the index to j plus 1 and we are going to iterate through the array. So every time we are going to take absolute value and set that index, check whether that index is less than 0. That is already negative. If it is already negative, it is simply going to have the same value. If not, it is going to update it with a negative value. So once that is done, we are going to reiterate and check if any number is greater than 0. If it is greater than 0, that index is going to be, that position is going to be the number which is missing from the given array. If not, if all the numbers are present, then finally we are going to return last position plus 1, which is j plus 1. So let's run the code. Yes. So yes, it is the fastest solution out of all. That is, it runs in 0 millisecond. So I think this is a interesting application of Quicksort to solve a problem in lesser time. Hope this video is helpful. If you like the video, hit like and subscribe. Thanks for watching. Thank you.